This is a story and use case about IBM Cloud for VMware Solutions. Cooking is a large and well-established food and food-related product brand. They actively engage consumers via a social website where they advertise their products in a low-key way, via publishing of coupons and recipes based off their products, and then encourage users to discuss cooking results and experiences with their meals and parties. Over the last 5 years, via analytics, Cooking has seen clear correlation between social web activity and sales. Cooking is a long-time VMware infrastructure user where they run most of their business, including the social web application. They have a single on-premise data center that's run out of Northern Virginia. Over the last year, as Cooking has modernized their website, user loads have also increased, which is a great thing for them. The downside is that they've been getting complaints of poor site performance during KBS periods. During KBS, site loads can peak by up to 1,000%, and this is growing year to year. KBS peaks last about 3 to 6 weeks, and then site loads return back to normal. KBS is an internal term at Cooking which stands for Key Baking Season. Cooking is running a project now to modernize their infrastructure with the following goal: ensure high availability via multi-region, multi-site configuration, upgrade hardware, and most importantly, handle KBS loads efficiently. After a thorough review of all options, Cooking chose VMware Cloud Foundation on IBM Cloud as the solution. With IBM Cloud, Cooking can link their on-premise VMware installations to a Cloud Foundation deployment in IBM Cloud, running the latest supported VMware hardware in a state-of-the-art data center with a true global footprint. Cooking's IT department doesn't like to make drastic changes. They like to ease into things over time. Initially, they will continue to run most of their social site on-prem and then transition a small set of workloads to IBM Cloud. As Cooking gets more comfortable with IBM Cloud, they plan to transition the bulk of the social site to run on IBM Cloud. Cooking also wants to leverage IBM Cloud service catalog offerings that can be deployed with the click of a button. Specifically, they have an interest in vRA to automate handling of KBS peaks. In addition, Cooking can easily add and shrink IBM Cloud capacity as required during KBS to handle the large increase in web traffic, only paying for what they need when they need it. Cooking decided to go with a software-defined network, or SDN, using VMware NSX. They can use NSX to create a secure stretch L2 network from their on-premise data center to IBM Cloud. They chose to deploy their Cloud Foundation in California for geographic separation of data centers. They created a logical network overlay on top of the physical network where their web server workloads will run. Incoming traffic still ingresses into the Northern Virginia, Washington, D.C. on-prem site, and then they are using an NSX edge with load balancer to spread traffic across their local data center as well as into IBM Cloud. They can burst more web workers into IBM Cloud during KBS season. After deploying Cloud Foundation with AD-DNS, they linked their on-prem vSphere instance with the Cloud Foundation instance using enhanced link mode. They can now see and manage both instances from the same vSphere UI. They also linked Cloud Foundation's NSX Manager to their primary on-site NSX Manager. This is Cooking's on-premise data center in Washington, D.C., Northern Virginia area, and this is where they're currently running their web server infrastructure. Above, this is the Cloud Foundation instance that was deployed in San Jose, California, in a geographically diverse region from their Washington, D.C. data center. Cooking started off with installing vRealize Automate in the San Jose Cloud Foundation instance. Cooking is using vRA to build a blueprint of their web server infrastructure so they can easily deploy additional load balanced workers as needed to handle high traffic loads such as seen under KBS. This here is Cooking's social website, and as you can see as I refresh the page that it's very responsive in its current state under normal conditions. We've also installed Locust. Locust is a web blaster and load testing tool. With Locust we can simulate typical web traffic and also KBS traffic. Right now, as shown before, we have one web worker on-prem to test how it handles typical traffic. Cooking will have about 500 users at any given time during typical traffic loads. You can see here that the on-prem worker can handle the normal loads. Now we'll crank up traffic simulation to KBS loads and see how the single on-prem worker instance responds. Cooking can get to 5,000 users during KBS at any given time. You can now see that the web server failure rate is climbing and that the on-prem worker is getting overloaded. Now using vRealize, let's burst additional workers into the cloud and get those web worker instances configured into the load balancer rotation. I'll deploy 10 more instances of the worker pattern to handle expectations of 10 times the web traffic. It's about 10 times the web traffic that we see in KBS versus what we see under normal loads. The request is now in progress. Let's go back to the IBM Cloud vSphere instance and check how those deployments are doing. I see the cloud bursting capacity is quickly ramping up to handle those additional KBS loads. vRA is now completed bursting the additional workers into the cloud. I'll go back to Locust to restart the KBS scenario test and see how Cooking's website performs. Cooking's website is now seeing activity from 5,000 users and all is well. Cooking can go back to what matters to them most, making the world a better place.